Okay, during the electrolysis of a salt of metal M, so we don't know the metallic part of the salt, a current of 0.5 ampere flowed for 32 minutes and 10 seconds. And they're supposed to be and deposits 0.325 gram of M. What is the charge of the metallic ion or the metal ion? Okay, um, normally we know that the mass deposited for any metal depends on the valency of the metal. So if a metal has a charge of just plus, it will take 1 farad. If it is a metal that has 2 plus, 1 mole will take 2 farad. 1 plus 1 mole will take 1 farad. 2 plus 1 mole, 2 farad. 3 plus, to discharge a metal of charge 3 plus 1 mole, you need 3 farad. So if you want to discharge 2 moles of a metal that has a charge of 3 plus, you would need 3 farad for each times 2, you will need 6 farad. That's how it works. Okay, so let's apply that here. Now, first of all, we were told that 0.325 gram was discharged. So let's find out how the quantity of electricity in coulomb. Farad, 1 farad is 96,500 coulomb. Coulomb is the quantity of electricity given by the relationship current times time of flow. Okay, the current multiplied by how long that current flow. So here we have 0.5 as our current, and now time. We have 32 minutes 10 seconds. Okay, we have to multiply 32. Let's do that somewhere. 32 times 60, right? Then whatever we have as our answer, we add 10 to it. Okay, so 6 times 2 is 12, right? And 2 carry 1. Then 6 times 3, I think that's 18 plus 1, 19. So 19 with a 0 here from this, then plus 10. Okay, so we'll have 1, 9, 2, no longer 2, now 3. So I'll take that out. Okay, 1930 after adding 10. This is our time in seconds times 0.5. Okay, if I break this down, this 0.5, if you multiply by 0.5, you're just dividing by 2. So 2 into 19, we'll have 9 remainder 1 here. Okay, and then 2 into 13, we have 6 remainder 1 here, and 2 into 10, we have 5. Okay, so this is a column that did the job on 0.325 grams. Okay, so the mass of this compound was given as part of the question. Sorry, it wasn't originally written. The mass is 65 gram, and Faraday was also given as 96,500. Okay, so we continue. Now, since this mass was discharged by this quantity of electricity, 65 gram would have been discharged by what quantity of electricity? 65 times 965 divided by 0.325. Okay, and the answer is 17921. Just do that up with a calculator. This is what you get. All right. Now, this is a quantity of electricity. Let's try to convert this to farads. How many Faradays are in there? So 17921 divided by 96,500. The answer is 2. So it takes 2 Faraday to discharge 1 mole. This is the atomic mass, the molar mass, because it's a monoatomic element. So the mass of 1 mole is just the relative atomic mass, just the atomic mass. And this is the mass for 1 mole, and it took 2 Faraday to get it out. It means that element M is charged as 2 plus. Easy.